Okay, let's take a look at a function, the same example of this function, this radical function here, and its inverse that I created by switching the domain and the range, right? So again, in a previous video, okay, when we were talking here, we said one interpretation of an inverse is switching the inputs and the outputs, right? Flipping the X and Y columns and flipping the ordered pairs, okay, to get these other ordered pairs of the inverse. All right. Now, in the interest of time, and because my hand is not as steady on this tablet and I didn't want to waste your time, I graphed these already here and I've color coded them. So if you look at this same set of uh, X and Y values for the original function, we see that graphed here, right? We see that sideways parabola as best as we can, graphed by hand here. We see this sideways parabola, okay, for the green values. The red values here are the X and Y columns from above flipped, right? So we took this Y column and we made it the X column, and then we took the X column, made it the Y column, and that created this inverse function. Those have been graphed here in red. Okay, now if you notice the way that these are graphed, okay, there's a very special characteristic, a connection between these graphs, and here it is. Okay, if you take the green function and you take all of its points, see if I can get this correctly, right through there, okay? And you reflect them over this line. Now, this line is what we call the identity line. I'm gonna write this out, okay? Identity line. The identity line is the line y equals x, right? So it has a slope of 1 and a y-intercept of 0. It literally cuts the first quadrant directly in half, right? Cuts through the origin and comes all the way down like this. So if you have a line that has a slope of 1 and a y-intercept of 0, it would look like that. Now, if you look at the connection between the green graph and the red graph, and again, allowing some forgiveness for my unsteady hand here, the red graph is a reflection of the green graph over this line. Okay, each one of these points, okay, maps onto its inverse point down here, okay, as best as I can, immediately over this line, right? So a different interpretation of inverses when we talk graphically, okay, is it's a reflection over y equals x, and oops, y equals x. So this is how we can interpret inverses. We can interpret inverses as switching the domain and the range. That's one way to think of an inverse function. A different way to think of an inverse function is as a reflection over the line, y equals x. Okay, and that happens because of us flipping the x and the y values here. All right, let's look at a different interpretation here in another video.